Bluetooth. And that is Marley. Hey, Marley, how's it going?
It's good. I'm in a sweater, so it's warmer in my office now, but it's fine.
Yes, it is a bit chilly here today, but it is Lunar New Year. Well, it was on the weekend, still celebrating, of course. So we thought for this edition of Ask an Astronomer, we should bring in an astronomer who has celebrated Lunar New Year back in China, is here in British Columbia. They are a PhD candidate at the Department of Physics and Astronomy at the University of British Columbia, and that is Yukun Huang. Hey, Yukun, thanks for coming on the show.
Hello, Michael. Thank you for inviting me to your show. First of all, I wanna say Happy Lunar New Year, 新年快乐 to all the audience. And yeah, I like to share something about Chinese space program in today's show, and yeah. I'd also like to talk about a little bit about all my research about the rogue planet thing.
Oh,
so
cool.
Yeah,
and we're super
thank
excited.
You for reminding me.
Yeah, super excited to get into that. First off, we actually did an event, here with the Chinese Canadian Museum at the Mid-Autumn Moon Festival. It is the Year of the Rabbit, and during that festival, we learned about the Jade Rabbit, of course. And so Marley's got a cool picture about that. I'm curious, before we get into this, Yukun, when you were back in China, did you have some favorite traditions that you would do during Lunar New Year?
I think my favorite tradition would definitely be basically just playing firecrackers with all my friends, because it's such a fun activity when you grow up as a kid in China. So these things, so there are different types. There's if there's a type of firecracker, you can basically do it as a match, and it will light up immediately. And then there's another type of firecracker you can just slam it on the ground and will explode immediately. So it's super fun. And you also got to play firework. A lot of great firework during the Lunar New Year. And as a kid, you also receive tons of red pocket money from your relatives. That's you gotta buy a lot of things you want. So yeah, it's really fun. And during the New Year Eve, which we call 除夕, we have the family union meal during it's either a lunch or dinner. And at the night, most of the Chinese people would watch what's it called, 春晚, which is just a TV show hosted by the CCTV, which is the Chinese television. And it used to be okay, but these days it's getting worse. So yeah. And the second day, which is the first day, 正月初一, the first day of the first month of the Lunar New Year, my family and I would go to the temple fairs. We would basically wish for better luck in a Buddhist temple. Okay. So, and you can also eat in the temple. They have nice meal. So okay. That's all my memory celebrating Lunar New Year as a child.
That's great. Yeah. And so you talked about the Lunar New Year, and of course we use the moon, and a lot of cultures do and have and still use the moon as a marker of time. So Marley, before we get into Yukun's work and some of the things he wants to talk about, why don't you go over how the lunar calendar works?
Of course, easy to go over. It's all deals with stuff that we see in the nighttime sky, everything we see with the moon. This is the image of the jade rabbit you were talking about, Michael, in the beginning. With it's a shape you can see, or some people can see, out of the craters on the moon. It actually, the shapes that are in that differ from country to country and people, groups of people to groups of people, what they see. It's really kind of cultural based what that ends up looking like depending where you are, which is always really cool. I think in Western United States and here in Canada, it's the man in the moon, but I also, that's harder to trace out. The rabbit was much easier to show than
and
that.
It's cuter.
It's cuter, yeah, that too.
Right.
So
And of course, for everyone watching out there in YouTube land or on Facebook, let us know what you see in the moon in the chat. And of course, like as we go through, just a reminder, throw in your questions. We will answer any and all your questions. Sorry to interrupt you, Marley.
Oh, no, that's fine. The lunar calendar, really to understand it, we have to understand the lunar phases and the times between them, right? So remembering that the moon does not shine, it doesn't have its own light, it reflects the light of the sun, and we always see the same side as it's tidally locked to Earth. So we end up seeing all the different phases of the moon. There's 8 or so in total. You know, going from new moon to new moon is what we call one lunation, or one cycle, completing one cycle. So this is just
I haven't
a
heard that before.
lunation. Yeah, it's fun. It's a fun word. This is just an image kind of showing, you know, how the moon looks from Earth at any given time, right? During some time in the month, what we're seeing at any time in the month. So what is a lunar month? If it's a lunar calendar, we assume it has months segmenting it, just like the solar calendar does. And there's actually 2 different lunar months. There's the sidereal month, which is when the moon returns to the same position relative to the fixed stars in the sky. So it ends up in the exact same physical location. And then there's the synodic month, which is the complete one cycle of phases. So that's when you would go from new moon all the way to back to new moon. That's your lunation. And the sidereal month is about 27 days, whereas the synodic month is about 29 and a half, right? So that's where we get our time from. Lunar calendars, because it's much easier to see the phases of the moon instead of looking for a fixed relative position, right? All throughout human history, it's much easier to tell when the moon has returned to the same phase. Use the synodic month, or that 29 and a half days.
Okay.
So then we come into a problem, though, because the Earth goes through its cycle around the sun in a one solar year is 365 days-ish, give or take a bit. And a lunar year is, you know, you have the 29 and a half times the 12 months, and you get 354 days. So we have a difference of 11 days. And so eventually you will run out of sync. You know, after 33 years, you'll be behind a year difference between the 2 of them. And a result of this is that eventually, if you were to solely follow the lunar calendar, you would end up with seasons not matching up, right? So you would be in winter according to your calendar, but it would be summer. And that really does not bode well for agriculture or anything that people relied on when it comes to using calendars for. And so what the lunar calendar, when most cultures and peoples refer to a lunar calendar, is actually a lunisolar calendar. So kind of a combination between the 2 of them. And so you add in, just like we have a leap year with our solar cycle around the sun, we in a lunisolar calendar will add leap days and even leap months to bring things back into balance. So if one tropical year, which is us going, the Earth going around the sun, is 365.2425 days, and one synodic month is 29.5, a tropical year is 12.38, right? So it's not quite a third, and it's not quite a half in either way. And so you end up getting a leap month every second or every third year. Kind of depends on the people, the culture who's using the calendar, when that happens. So that is the lunar calendar. This year, I don't think there's a leap month this year, but I can't remember. I might be wrong for this lunar calendar, the Chinese lunar calendar. But
yeah, I think it's super cool. I mean, it's one of those things that as a kid, I always thought that it would be way better if we could just like use the moon as like a calendar. I kind of like that idea. But of course, it would be difficult, I think, like to get everyone on board. It does make sense, you know, to have this universal calendar that we use now. Throw in the chat if you think that we should go back to the lunar calendar. You know, get rid of these 31, 29 days, you know, let's get weird with the lunar calendar, I say.
Well, the lunisolar calendar, like sometimes it has, you know, either 29 or 30 days. Like it also doesn't have a consistent month, a length of month, right? Because you can have that leap day, right? I think it was the Sandrian people who were Hebrew people who would decide whether or not the month would have 29 or 30 days in it after a new moon, right? So they would have to go and meet and confer. They were all trained in astronomy and studying the moon and seasons, and then have to decide whether or not that month was going to be 29 days long or 30 days long. Because 29 and a half this is how I explain it to kids. It's like if you were going through your day and it's the end of the month and you get to lunchtime and it's December 31st or whatever at lunch at December 31st noon, it's now 2023, like it doesn't make any sense. The day has not passed with the sun in the sky. So it's tricky. It's
Yeah.
tricky.
Yeah. Another fun fact I can add up to the Lunar New Year or Lunar solar calendar is that actually the older generation in China, they tend to celebrate their birthday using this lunar solar calendar. For example, my dad grew up in rural China, and his birthday is always celebrated during the same lunar solar date instead of using the Gregorian, the Western calendar. But my mom, who like have a different background. She is like grew up in like towns, not rural China. She just celebrate her birthday using a Western calendar. So I think that's super interesting.
Very cool. Now I'm curious. I'm gonna look up my birthday on the lunar calendar and
go find it.
All right. Well, you can. We brought you on the show. Before you get into it, we're going to have a little cool story about the Chinese Space Agency. But why don't you tell us about some of your work? You're a PhD candidate at UBC. You actually work with one of our interpreters here, Matthew Baudouin. Shout out to Matthew if you're watching. But you can tell us about some of your research first, and then you can get into your story about this Chinese Space Agency.
Yeah, sure. Let me just share my screen so it's okay. Can you see this?
Yeah.
Okay, so I'm doing basically solar system dynamics, especially in the outer solar system. So we all know that the solar system consists of like 8 planets, and there are a bunch of small bodies, which are also called asteroids, in our solar system. For example, this top left panel shows you the orbit of all the terrestrial planet and Jupiter, and in between Jupiter and Mars, there is the asteroid belt. And let's go further beyond the orbit of Neptune. There is, you probably have heard of the concept of the Kuiper belt. Kuiper belts are basically the solar system small bodies beyond the orbit of Neptune. And one of the Kuiper belt objects, whose name is Senna, was discovered in 2003. And it has a really bizarre orbit. You can see so its orbit is like connected to none of the giant planets. So because of this, it's very hard to explain how what mechanism could have created Senna. How could Senna formed using the solar system model? By solar system model, I just mean like using all the known planets from Mercury to Neptune. So it's very hard to explain Senna's creation. So therefore, one of the goal of my thesis is trying to explore the idea that there might have been an extra Earth-scale planet in the early solar system. And the story of the creation of Senna could have been it's dynamically created during the short presence of this 5th planet in our early solar system. So we called this planet, let me try to, oh my bad. So we call this planet the Roe planet. So it basically means it just wandering in the solar system for a short period of time, and because of its presence, its gravity can pull up the orbit of Senna and put Senna or other objects like Senna into their current orbit. So that's basically what I've been doing during my PhD thesis. And it's fun because there is actually a movie that kinda have a similar idea. So it's called, I don't know if you have heard of the movie called The Wandering Earth.
Oh yeah.
Yeah, it's the original. It's adapted from an original novel by the famous Chinese sci-fi writer Liu Cixin. So in this novel, he envisioned that the habitability of the solar system is no longer suitable for us humans. Thus, we must push the Earth out of the solar system and let the Earth become a wandering planet. And I feel like it's such a coincidence that I'm not exploring the sci-fi idea, but I'm exploring a very similar idea that there might be a wandering planet or the rogue planet in the early solar system. So
yeah, very interesting. And so just to clarify, when you're talking about Sedna is now classified as a dwarf planet. Is that correct?
Oh yes, Sedna is a dwarf planet, but because it's just like Pluto. So both Pluto and Sedna, we call them a dwarf planet, but in a dynamical point of view, which means if we're going to study their orbital evolution, their mass is unimportant. So even we call them dwarf planet, for me, they are just like other asteroids because we never consider their mass. Yeah.
So it's back to that age-old question of like trying to like name things, and then it gets frustrating because like, well, it depends on who you ask. Like if you ask certain astronomers, they may give you one answer. And looking at this picture of Sedna in your bottom right there, like. If I didn't know that was a dwarf planet, I would like maybe guess that that's the orbit of a comet.
Oh,
because it's very elongated.
Yeah, that does look like an orbit of a comet, but there is a very significant difference between a comet and let's call it the outer solar system bodies, which is comets is supposed to doing the outgassing, which means it release gas from their surface. Well, that's the process that make them so bright in the sky and can be observable even with our human eyes. But instead, these objects, these capable objects, they're super faint. They cannot. They're beyond what the human eyes can see. You have to use really advanced, really big telescope to resolve them, to see them. So in that sense, they look nothing like a comet. So because comets tend to be much brighter than a TNO does.
Yeah, very cool. If you're watching, if you have any questions for Yukun about some of his work, it's got one more question because you just talked about the type of telescope that you would need to see Sedna. So what telescopes are you using?
Actually, I never use telescope.
I know you probably use data, but
because I would more comfortable calling myself a dynamicist, instead of astronomer, because I never did any astronomical observation. But I do know, like my supervisor Brett Glanman, who is both the dynamicist and the astronomer. He when he is doing his research, he used a telescope like the CFHT, which is called the Canadian France Hawaii telescope. On Hawaii, that's a really advanced telescope that can that help us understand a lot of Kuiper belt objects beyond Neptune. So that's one telescope, and there is also the Subaru telescope by Japanese people, and there is a future telescope that is very relevant to my research. Is called LSST, or the Very Rubin Observatory. It's located on a mountain on Chile. So yeah, that's gonna be the future of solar system science.
Okay, yeah, this is Ask an Astronomer. It could be Ask a Dynamist. Maybe we'll have to rename it just for this one. But let's move on because you've got a story. The Chinese Space Agency. We do talk about a lot here at the Space Center because they're doing a lot. Like over the past time that I've been here at the Space Center, it's gone from like very little to like a lot very quickly. We're hearing a lot more about them. Sometimes it is a little difficult to get information about them, but you've got some cool stuff that they are doing. So what is going on at the Chinese Space Agency that you want to share?
Yeah, so that's a good question. So China has put some effort into space exploration. So like I think it's 2021 or 2020, China launched its first Mars mission called the I don't know the English. It's called 天问一号, the 天问 one, the first 天问 mission. So 天问 is from a poet back in ancient China. That's just another story. And China is gonna launch its second 天问 mission and third 天问 mission. And the second 天问 mission's target is this very peculiar asteroids near Earth called a quasi-satellite. So its temporary name is called 2016 HO3, but you can also call this objects a quasi-satellites. It's like the Earth Moon, that is orbiting the Earth, but it's like much further than our moon, and it's on a larger orbit with the same orbital period as the Earth. So in the eye of the Earth, it looks like it's orbiting the Earth itself. So we call this type of orbit not moon, not strictly Earth moon, but quasi-satellite orbit. And it's very interesting because there is a recent study published on, I think, Nature Communication. So a bunch of astronomers studied the spectrum of this peculiar objects, and they found they looks very much like a rock from the moon. So it's by spectrum, it looks like a rock from the moon. And so that poses a question like, is this really an asteroid or a rock from the moon? And this Chinese space program, this Chinese space mission is gonna find out its composition, its physical property, and its mass in I think in 2027. I couldn't remember the year. So they're trying to have a sample return mission, grab a bunch of sand or rocks from the surface of this asteroid and return it back to our Earth. And after that, so we can also see this figure. So it really took me a hard time finding a picture about Chinese space program. So this is in Chinese. So in about a year, so after its launch, in about a year, it will orbit the asteroids and do the sample return and retrieve some sample from the surface. And after half a year, it will return the sample to Earth. And there is another mission which is flying further into the deep space, and took 7 years before it detect another comet. So it's like a two-stage program. The first stage is exploring this asteroid, and the second stage is exploring I believe it's a main belt comet. I couldn't remember. It's some comet. So that's basically what the Chinese Space Agency is going to do in the beyond Earth in the next couple of years.
Yeah, that's very cool. And I'm curious, you grew up in China, and you said that in the past few years, activity in the space agency has certainly ramped up. For you, and I'm curious about say people that back home, like maybe your family, and maybe they're not dynamists, like you, that are super nerdy about this, but is it big news, what the Chinese Space Agency is doing back home?
Yeah, I think it's definitely a big news. I still remember when I was a undergrad student, in the what's it called, in the aerospace department, we have like watch party for the launch of the Chang'e mission, which is China's moon exploration program. So we're really excited when the Chinese rocket actually put the first Chinese rover on the surface of the moon, and it's really a big story, and I can definitely see its impact on Chinese people, especially young people, Chinese students who want to push forward the frontier of exploration. So it is a big thing, and China is also like building its own space station, and it's doing its Mars exploration program. The first one has already succeeded, and the third Tianwen mission is gonna retrieve sample from Mars, if I remember correctly. So it's a really steady and I would say practical space program in my view. So yes.
Yeah, that's interesting. And they seem to be doing a lot of like planetary stuff,
Yeah.
which is very interesting. And of course, that's probably, what interests you, as a dynamist, and obviously doing your work with Brad Gladman, who is very interested in some of these, I would say like the other smaller bodies like asteroids, and or the dwarf planets, if you will. So, and that's, probably interests you. Like you had mentioned that story, that Wandering Earth was based on. Did that inspire you? Like what? I'm curious about like what inspired you to get into the work that you're doing now.
Yeah, I feel like I'm definitely inspired by Liu Cixin's story. He wrote the award-winning sci-fi trilogy called The Three-Body Problem, which the core of this novel is basically like it's really hard to solve three-body problem orbiting each other because it's mathematically impossible. Like it's a really hard problem, and that actually get me into like the big territory of celestial mechanics, because I'm quite fascinated by the novel itself, and I feel like part of me was inspired by the novel and by the sci-fi writer to study orbital dynamics and the motion between planet and small bodies. Yes.
Very, very cool. So we've only got a few more minutes. So if you're watching, you want to get in a question for Yukun or for Marley on any topic in the universe, you can throw it into the chat. And if Marley, if you're still around, we could probably end off maybe on our last little news story. I know that lots of people, and I know you've been getting some calls about this comet. So if you want to stop sharing your screen, we can maybe throw up a picture of this comet, Marley. What's going on in the skies?
What is going on? Yes, sorry, Yukun, I'm stealing the screen sharing.
My bad.
Okay, it's okay. So this comet, it's loading. There it goes. Comet C22E3ZTF still hasn't been given any other name. It's still going by this really long name. Its closest approach is coming up. It'll be February 1st, and it'll be circumpolar that night. So it'll be visible all night, and a dark sky area and binoculars are the best bet. I always recommend getting out of the city for these sorts of things. And I did check with some of my colleagues here who work in the observatory here, and they came to the conclusion that it would be visible through our telescope. We were concerned because we have the North Shore Mountains right there, and weren't sure how high up it would get above them, and then also the trees and the skyline that we have. But it is above, and so you can't walk into the observatory anymore, but it is included in our Wednesday and Friday night programming, which when we're open from 6:30 till 11 p.m. So if you wanted to come check it out, you could that night. Keep in mind that it's weather dependent, right? Like, given what's going on outside. So, but it should be up there. It'll be up for a bit longer after that as well, but it'll be up less and less as it finishes its close approach and heads back out of the inner solar system.
Yeah, there you go. I mean, I saw my first comet, Comet Neowise, a couple of years ago.
Oh, that's also my first comment.
Yeah. And of course, like there was like, I don't remember Hale-Bopp, or Comet Halley. But it was fascinating. Like to
Mm.
see these pictures and then to see with your own eyes, the tail, this bright body. It's really cool to, I think, see the connection of these celestial things with your own eyes. So I certainly encourage everyone, if you can, try to go and see it. I know it will be challenging. So next clear night, everyone go and check out the comet. And Yukun, thank you so much for joining us on this edition of Ask an Astronomer. For all of you out there watching, happy Lunar New Year, happy Year of the Rabbit. And as Keith mentioned, in Vietnam, it's the Year of the Cat.
Yeah.
So hopefully the cats and the rabbits will get along in this year. And for all of you, we will be back in 2 weeks on February the 9th with a very special program because February 10th is something that we have done as a tradition here at the Space Center, Space Debris Day. If you're not sure what Space Debris Day is all about, well, you're just going to have to tune in. On February 9th, we're going to have 2 very special guests that are going to talk about a very burgeoning field that affects everyone. And that is the stuff that is out there floating around the Earth. So tune in to the next episode of Ask an Astronomer Space Debris Day. Marley, thanks as always. Yukun, we will see you all next time.
Thank you.